Hello, everyone, and thank you for joining us today for the Pytes Battery webinar, Affordable Whole Home Backup Pytes V5 LFP Battery Systems. Just a few quick items before we get going today. So during the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, please feel free to use the Q&A button at the bottom of your screen to type in your questions. They will be monitored throughout the presentation, but we'll probably keep most of them till the end of the presentation. This webinar will be recorded and shared with all of you within 1 week of today's session. And it is my pleasure to introduce our presenters from Pytes, Austin Lee and Logan Basher. With over 8 years experience in the solar and energy storage industries, including 2.5 years with Pytes, Austin Lee is the Senior Sales Manager leading Pytes Energy Business Development Services in the US and Canada. His expertise spans solar and energy storage systems, UPS, lithium ion battery systems, and customized power products. Austin specializes in strategic sales and marketing, planning, and implementation. Logan Basher graduated from Northern Arizona University with a bachelor's degree in both mechanical engineering and Spanish. He has been in the solar and storage industry for over 7 years now. Before joining Pytes, he worked as a solar applications engineer, where he focused on system design, equipment sales, and technical support. Last February, he began his role as product manager with Pytes. And without further ado, I will pass it over to you, Logan, to get us started.
All right, great. Thank you, Tatum, for the introduction. I'm so happy that all of you could join us today, and I'm excited to share with everybody a little bit more on Pytes and our product and how we can both work together to be successful. I have to apologize off the bat. I'm having some issues with my camera this morning, so I'm not sure if we'll be able to see me, but hopefully we can all see the important part, which is the presentation. So as Tatum said, I'm Logan. I'm the product manager for Pytes. Today, I'm going to be talking a little bit about our company, sort of the background, a little bit of the structure of Pytes, what we do, who we are. Most of the presentation today is going to be about the V5 battery. That's the primary product that Charge Solar is going to be using. So we'll talk a little bit about that battery, some of the accessories we use for it, a few configuration examples, closed loop, things like that, a little bit about our installer support and resources. And then right at the end, I'll spend a bit of time just introducing some of the other products in our ESS family. Won't spend too long on that, just because, again, the focus for today is going to be V5. So we'll go ahead and jump right into it. We are Pytes USA. We've been around for about 20 years now, founded in 2004. Originally got our start making small batteries for consumer electronics, small electric vehicles. And then within the last 7 or so years, we got into the world of energy storage and ESS. So we are based in Shanghai, China. That's where our main office and manufacturing facilities are. We have a couple of other facilities in Shandong, China, and Vietnam. So altogether, it's about 600,000 square feet of total combined manufacturing space across those 4 facilities. And these days, we do have now well over 1,000 employees worldwide. So as I said, originally got our start in the world of small consumer electronics. This is sort of how our company as a whole is structured. 3 main divisions for the most part. Consumer electronics, those are going to be things like toothbrushes, portable lighting, service robots, medical equipment, among other things. After that, we broke into the LEV sector. So LEV is light electric vehicle, things like e-bikes, scooters, motorbikes. And then just within the last 7 or so years, we have been developing energy storage systems or ESS solutions. So we do ESS for both residential and commercial and industrial projects. So these are just a few of our main partners or key customers for the consumer electronics and LEV division. Nowadays, Pytes is actually one of the top e-bike battery providers in the United States. And I'm sure everybody recognizes, a few of the brands on this page here. So very well established in terms of manufacturing, battery production, BMS development. We've just sort of gradually started scaling up the operation to incorporate the ESS products. Both of these divisions, by the way, are still very active. So we are still involved in the consumer electronic small scale market and LEV as well as ESS nowadays. So Pytes, we are indeed a true global company. I kind of showed our main headquarters there in Shanghai, some of our manufacturing facilities in China and elsewhere in Asia. In terms of North America, we have our main office and headquarters right now is in Dallas, Texas. We also have stocking warehouses in Los Angeles, Puerto Rico, and Panama, as well as facilities throughout Europe and a couple other places throughout the globe too. So really just trying to be as present as we possibly can. And we keep stock in all of the North American warehouses as well, just to try and make sure we can get our customers' product as quickly as possible, not just for new orders, but for warranty replacements and things like that. So now that we all know a little bit more about Pytes, who we are and what we do, we'll jump into more of the technical related content. So I'm going to introduce our one of our main products for ESS. This is our V5 lithium battery. So this was a product that we released in 2023. It was sort of a new and improved upgraded version to our original server rack style lithium battery. That was the e-box battery. I'll touch on that way at the end of the presentation. But anyways, the V5 has been in the market for a little over a year now, going on a couple years, and has been very successful so far. Again, we took a lot of the feedback and suggestions from customers and installers about the original e-box battery, and then tried to incorporate as many of those as we could when we developed the new V5. So I'll touch on some of the key features on this product, just to make sure we're all a bit more familiar with it. So one of the first things to point out is the safety and reliability of the battery here. We use tier 1 automotive grade A prismatic lithium iron phosphate cells, not just in this battery, but in all the other batteries in our ESS family. The V5 also, we have UL 9540, UL 9540A, and UL 1973 certifications. This product has a 10-year warranty, and it's rated for 6,000 cycles at 90% depth of discharge. The V5 is an extremely scalable solution, so we can actually have up to 16 batteries in parallel without any additional equipment or accessories. So 16 of the V5 batteries, it's about 82 kilowatt hours total. You can build a system all the way up to 96 total batteries. So that's 6 groups of 16 batteries. That's going to give you close to 492 kilowatt hours. There is a special accessory required called the hub in order to build a system that large, and I'll show that a bit later as well. But really anywhere from a single battery, which is 100 amp hours, 5 kilowatt hours a piece, all the way up to 96 total batteries, just under 500 total kilowatt hours. So this is a very, very scalable solution, and works for extremely wide range of application and system sizes. One of the improvements we've made on the V5 compared to the first server rack battery we released was a wider operating temperature range. So the way we've accomplished this is integrating a heating pad inside of the battery. That'll come on when the battery is below a certain temperature and allow you to do more charging in lower temperatures. So really opens up the door for more flexibility when it comes to installations, more options in terms of where we can locate and house batteries. I know for you all in Canada, with winter temperatures being very cold, I think this integrated heating pad is a very important important feature. So another one of the big improvements on the V5 is a higher charge and discharge rate. So our first original battery had a 50 amp, that's a half C charge and discharge rate. The V5 improved rating is 75 amps charge and discharge per battery, which is about 3,800 watts of power. Now, the battery can achieve a slightly higher charge and discharge rate up to 1C, which is 100 amps. That's basically about 5 kilowatts of power you can put into or pull out of the battery. To get this 1C charge rate, that does require a special firmware update. Most of the time, we found that the 75 amp charge rate is perfectly fine. Again, given how scalable the batteries are, right? If we need more charging or discharging current, it's as simple as just adding, more batteries to achieve that value. So this 1C rate, I'd say, is reserved for very special or specific cases. That does have the potential anyways to shorten the lifespan of the battery. So we like to keep it at the 75 amp rating as much as possible. And again, that should work for most, if not all cases. Not to mention as well, we do have some peak discharge on the battery as well. It'll do all the way up to 180 amps of discharge for 15 seconds at a maximum. So that's there to help with spikes and loads, startup surges for big inductive loads, maybe helping to handle inverter capacitors when you make that initial connection for the first time. So pretty robust current range on the V5 battery. And then one of the last things to point out, again, just kind of another improvement we've made, is the availability or accessibility of data and information on the battery, which is accomplished, or can be accomplished, I'll say, with an accessory, a Wi-Fi dongle. So this is basically a device that will plug into the battery that will let you or your homeowner client monitor the batteries remotely. And I'll touch more on that a bit later, but very powerful, important feature now that's included on the V5. So yes, that's kind of a brief introduction of the V5 battery. Just some of the standout points. One thing to note here, not just specific to the V5, but for the rest of the ESS family, we have a very low failure rate. It's only 0.3%. Most of those have to do with BMS issues, not cell problems or anything related to that. And many of those cases are field replaceable. So our BMS board and the power supply board in the V5 specifically can both be replaced in the field. And because the failure rate is so small, and again, most of those have to do with BMS, there's very few instances where you as an installer would have to be removing this battery from your installation and packing it, palletizing it, trying to ship it back to us. So we try to make all of your lives as easy as we can, and the field serviceability on this product is I think is a very good selling point for this. So real quick, we'll just do a walkthrough on some of the main features on the V5. So starting with kind of the maybe two biggest obvious ones, the negative and positive power terminals over there on the right. We've got our LED indicators here kind of in the middle, tells you SOC running conditions, if there's an alarm or not. The power button for the batteries over on the left. We have a start switch, which essentially is used to take the battery system in and out of uh, between operating mode and standby mode. Each battery case has a grounding lug to ground the case of the battery. Here are the dip switches, which we use to set inverter communication protocols. We've got all of our communication ports right here. So CAN, RS-485. There's a console port, which we use to connect the battery to a computer for further diagnostics. And then the battery-to-battery communication ports are the link ports, which allow each battery in a specific group to talk to each other and share info. This one right here in the middle is the one of the new additions we've made on the V5. This is an IoT port, which is specifically used for that Wi-Fi monitoring dongle that I mentioned. And then lastly, we've incorporated a dry contact relay into this product, which can be used for ESS emergency shutoff if that's required for any kind of installation. So next we'll take a look at the packing list of the battery. This is essentially everything that you receive when you open the box of a V5. You get the battery itself. You get a short communications cable. This is designed to go from battery to battery. The grounding wire for the battery case. You get a pair of copper bus bars. These are rated for 300 amps a piece, and then a printed user manual. I believe you also get a couple of RJ45 plugs that don't have a cable attached, just in case you do need to make a custom communication cable to go up to the inverter. So the short comms cable here and the bus bars here only work out if you have the batteries in proximity to each other. So either like stacked one on top of the other, or if you had the battery laying on its side, kind of like a book in a bookshelf, if you will, and then neighboring batteries to either side of it could use the bus bars and these short comm cables. So if you're doing an install where the batteries are not physically near each other, maybe you're using custom racking, putting them on a wall, you may not be using the bus bars or the included comms cables, but we can kind of help and advise on what else would be needed in that case. So these are the enclosure and mounting options we have available for the V5 battery. These are kind of the four main ones we use. The one on the left here are just simple brackets that attach to each battery individually. You can have up to 6 batteries in a stack using those brackets. The brackets are really lightweight, they're inexpensive, they're easy to install. This is sort of what the final product looks like with the brackets. So we can see we've got a bit of clearance between the batteries, but there's nothing on the front or around the batteries, rather, closing them in or covering up the buttons or anything like that. So the next couple options, I'll sort of introduce these together since they're very similar, is our V-Box IC cabinet. There's an SE version and then a standard version. So these are essentially the same product, except the SE does not have cabinet walls or a door, and the non-SE does. Both of these have optional casters wheels on the bottom of the cabinet, so you can sort of make these mobile if needed. And you can actually stack 2 of the cabinets on top of each other if needed for the installation. So these cabinets, by the way, each hold 3 batteries, so 15 kilowatt hours, 1, 2, 3. You could have 2 on top, and that gives you basically a 30 kilowatt hour stack. This is an indoor rated cabinet, by the way. The last enclosure option we have for the V5 battery is our V-Box OC, which is this guy in the top left corner here. This holds 4 batteries. This is an outdoor rated cabinet and has integrated bus bars and breakers inside of the cabinet in this top wiring compartment there. So this is at the moment the only outdoor rated solution we have. These other 3 options that I'm showing here are indoor rated. So this is the Wi-Fi dongle or a remote monitoring accessory for the V5 battery. This is the LSW5 accessory. This is a really, really cool and powerful tool, something that we actually just recently released in the past year. But what this lets us do is it lets us view the battery information or system when we're not on site. So we do need a solid connection to internet, Wi-Fi, and as long as that's present, we can see pretty much everything that the batteries are doing from a remote location. So this is going to allow us to do remote firmware updates. We can collect information and history about the battery. We can look at faults. We can do more, I think, advanced or just faster troubleshooting. What's really cool about these the monitoring is it actually lets you see down to the cell level in each battery. So not only can you see data about individual batteries connected in a system, you can actually look all the way down to the individual cells in each battery in a system. So there's a lot of information that's available to you. The device itself is really, really simple. As I said before, this IoT port on the V5 directly accepts the Wi-Fi dongle. So it's super, super plug and play. The dongle itself is pretty basic. It's just got a couple of LEDs on the front, which let you know if it's got power, if it's got internet, if there's an issue. Because we have this dedicated port on the front of the battery, it does not conflict with your inverter communications. So if you're using an inverter that talks CAN or talks RS-45 for closed loop, you can use this accessory no problem. It won't interfere with our inverter comms. And these are the apps or the programs that we use to actually do the monitoring portion. So we kind of have two different setups here. We have SolarMan Smart, which is designed for end users or homeowners, and then we have SolarMan Business. So this is our app or our website for distributors or installers. So likely what most of you will be using would be the business version. So this is available in a mobile app and also as a web browser. The information that's available in either version is basically the same. It kind of just depends on how you want to access it or how you can access it rather. I'll say whenever possible, try to do the mobile setup with the smartphone or a tablet. It's literally a matter of just scanning the QR code that's on the dongle itself through the app during the initial setup or configuration. And it kind of automatically does everything for you. Web browser configuration is possible as well. There's just a few more steps. You essentially have to manually enter the serial number for the dongle directly instead of just scanning it from the app. But yeah, either way, lots of good info on both of these sites. And as an installer, as I said, you'd be using the business app. You can set up the installation of the plant so you and your team can view everything. And then you can send an invite to the homeowner and they can look at it on the SolarMan Smart version. So SolarMan Smart just has, I'd say, maybe less information and maybe more limited functionality compared to the business version. Okay, so this is an accessory that we use not just for the V5, but for the other products we offer as well. This is our hub device. So this is something that's required for larger systems. I should say larger closed loop systems that have over 16 batteries. So if you're using a closed loop inverter like Solarc, Lux, Mega Revo, Victron, and you have more than 16 batteries, we've got 18, 20 batteries. At that point, it is required to use this hub accessory. So really what this does is it facilitates communications between multiple groups of batteries. This doesn't have battery cells in it. This doesn't do anything with the battery BMS. It's really just a communications management device. And as I said, this is used for the other products in our ESS family as well. So we can take a quick look at the dimensions and some of the basic specs for this, but main takeaways, just remember it's needed for any system that has more than 16 batteries. The power consumption at 2 watts is pretty negligible, so we definitely don't have to worry about this thing like discharging batteries or adding some unnecessary drain onto the system. It's a very slim design. It does fit in a server rack shelf. The hub is an indoor rated component, right? So this has to be installed inside or in some sort of a outdoor rated housing if you have an outdoor installation. These are some of the other accessories that Pytes offers. These, in this case, just mechanical bus bars. So we've got a couple different options. We have a 300 amp hour bus bar and a 600 amp hour bus bar. Slight difference in the size and number of terminals, but at the end of the day, these two basically do the same thing. This 300 amp bus bar we normally see when we have, say, multiple battery groups or multiple cabinets that we need to bus together before we go up to an inverter. 600 amp hour, kind of the same thing, concept anyways, just for larger scale systems or higher current applications. Often I see the 600 amp hour bus bar used in cases where we have multiple inverters. Say we've got, 3 Solarc 15Ks. I think at that point we might need something over 600 amps, but yeah, for larger systems with more than one inverter, this is maybe what you'd be using instead of the 300 amp version. If we need, or if any of you need, recommendations for higher current bus bars, we're doing some huge monster system with 6 inverters. There are other higher current busing options available. I know Victron and Midnight Solar have some options for that too. So the last thing to show here is something that I think we use much more frequently than these 2 bus bars. These are our V bus bars, and these are specifically designed for the Solarc 15K. So as I'm sure some of you know, the Solarc 15K inverter has basically 2 positives and 2 negative battery terminals inside of it. What we like to do when it makes sense is use this V bus bar. You use one to join the 2 positives, you use another one to join the 2 negatives. What this lets you do is it lets you run a single set of higher gauge cable, heavier gauge cable from the battery bank to the inverter. Without these V bus bars, these aren't required for Solarc 15K installs. If you did not use these, typically we're looking at doubled up or 2 sets of 2-aught cable between the battery bank and the inverter. When we do have these V bus bars in play, that lets us do just a single cable run with 4-aught instead of the doubled up 2-aught. So I don't really think there's a right and a wrong way. There's pros and cons for each of those, but just know this is an option, something that we offer, and I think it does a really good job of cleaning up an installation, especially when you have a bunch of inverters. It just reduces the amount of cables that you have to run for the most part. These are some of our inverter partners in terms of compatibility with our batteries. Solarc, kind of the main logo in the front there is for sure our main inverter partner. We have closed loop with them along with multiple safety certifications. We also have closed loop with other manufacturers such as Victron, Megarevo, Lux Power, Growatt AP Systems. Some of these on the list are open loop. So for example, we can work with Outback, we can work with Midnight Solar, Magnum. It's just there's no communications. So the way in which you go about programming the equipment is just slightly different, but it still works. This list is always growing. So as we partner with more inverter manufacturers, we'll add those accordingly. So with Solarc, along with a couple of other manufacturers, we have full UL safety certifications. So specifically with the V5 and basically any model Solarc, the 5K, 8K, 12K, 15K, we have UL 9540, and the batteries also have undergone UL 9540A testing. So that 9540A test includes cell level, module level, unit level tests to um, uh, investigate thermal runway. And we have done that with the batteries, the V5 with all of those different Solarc models. Again, we have UL 9540. All of the V5 enclosures that I showed you on a couple slides ago fall under that UL 9540. And it's basically up to 12 battery modules per inverter. So if you have one Solarc 15K inverter, you can do up to 12 V5 batteries with any of those enclosures that I showed, and that whole system will qualify as a multi-part ESS under UL 9540. Let's say you add a second inverter to that example. Now we've got two inverters, and that means you can have up to 24 batteries and still maintain the certification. So in addition to Solarc, all of this here also applies to Megarevo and Lux Power inverters. So I know that that Charge does a lot of work with Solarc, but those are a couple of other inverter options that may potentially be a lower cost solution compared to Solarc. Okay, so the next few slides here, I'm going to talk a little bit about our V5 battery BMS, some of the logic behind the BMS limitations. And first, I want to talk about the heating function of the battery. So again, one of the big improvements on the V5, this has an internal heating pad, which I think for most users in Canada is likely a requirement, if not heavily recommended. So at the moment, currently the heating function requires an external charging source. So what that means is that the batteries do not discharge their own energy to heat themselves. They have to have a charge coming in, whether that's from a PV array, a battery charger, a generator, MPPT charge controller. It doesn't matter where it's coming from. But the battery heating pad itself has a very low power consumption. It's only about 3 amps DC per battery, which is about 170 watts. So again, you're not going to notice significant, I don't know, side effects in your energy production when the heating pad is in use. It's pretty efficient, I'd say. We can normally see the temperature rising in the battery of about 18 Fahrenheit, 10 degrees C per hour. As I said, this widens the battery's operating temperature range and gives us a lot more flexibility when it comes to installation and housing. And then the heating system has multiple protections, both on the software and the hardware side. Well over a 10-year design life, so we do not expect this component to fail or malfunction within the warranted life of the battery. So I'll talk a little bit about the logic of the heating function. By default, it's off. So default state, the heating pad's not working. It has to see the lowest cell temperature. And so 16 internal cells in the V5 battery, it's always going to look at the minimum value. So if it sees the minimum cell temp below 41 F or 5 degrees C, it will start heating, and it will continue to heat until it reads the minimum cell temperatures above 50 Fahrenheit or 10 degrees C. The lower, so low end limitation of the heating pad is minus 4 Fahrenheit or minus 20 C. That's kind of getting into the operational limitations of the battery itself. So below these temperatures, the heating pad unfortunately is not operating. I mentioned we do have some protections on this internal component in the battery. So basically the BMS is looking at the battery cell temperatures and how the heating pad is running or if it's not running. And depending on what's happening at that moment, it may give an alarm. So one of those protections is if the heating pad goes on, it's activated, and the battery doesn't detect a temperature change within 30 minutes. So in other words, like the heating pad is on and the battery thinks it's heating, but the temperature is not actually increasing. So that's going to indicate that there's a problem to the BMS, and it will give you an alarm and turn off for protection. Also, if the battery detects that the heating pad is running for 15 minutes or more when we have not hit this minimum cell temperature, that will actually cause the fuse on the heating pad to blow, and it basically takes it out of the circuit completely. So this is maybe one of the more serious alarms or protections. And again, the battery knows the heating pad is on, it's heating, it's increasing the temperature, but we never achieve this minimum cell temperature to begin with. So the battery is going to say, let's protect the cells. We don't want to be heating our insides when we don't actually need it. Similarly, if the heating pad is running for 3 hours continuously, it'll turn off, and I think it's a 30-minute delay before it comes on and checks again. And then kind of the same logic here. If the BMS sees that the heating pad is starting and stopping frequently, so off, on, within a predetermined amount of time, it will give you an error as well. The heating pad operation can also be controlled using our PC software. So for troubleshooting and kind of further testing, you can play around with it slightly. And we are currently, I know the requirement of an external charging source can seem limiting. We haven't really found it to be a big issue, but we are exploring the option to have the heating pad turn on at a specified state of charge in case there is no external charge available. So I unfortunately don't have a timeline on that right at the moment, but it is something we're exploring to see if that's possible. So a couple more things on the BMS. I'm going to go through a couple slides that just show how different parameters affect battery operation, specifically our charge and discharge rate. So this first one, we're going to look at voltage, battery voltage versus charge rate, and how it affects the charge rate. We don't have to focus too much on the details here, but just kind of the main themes or takeaways from this information here. I'll point out that in this range, 45 to 55 volts DC, everything's normal. So as I mentioned earlier, right, V5 battery is 0.75 C, charge and discharge rate, that's 75 amps per battery. So the percentage here is in relation to 100 amp hours. As our voltage increases, we exceed 55 volts. We're getting closer to the top end of the BMS. The battery charge current is going to start to limit itself until it'll basically prevent any charge from coming through if the voltage is high enough. So higher voltage, we're seeing our charge rate decrease, but our discharge rate stays the same. Opposite happens at the other end of the chart here. As our voltage gets lower, the BMS is going to prevent you from discharging. So our discharge current actually goes to zero, whereas the charge current remains at our full 75 amp value. So similar behavior with temperature as well, and how that affects our C rate. First thing to look at is our normal range, right? So 10 to 45 C, 10 to 45 Celsius, 0.75 C, 0.75 C. So between this temperature range, which is what I think 50 or so, sorry, no, 10, sorry, 10 to 45 degrees C, everything's normal. As we get colder temperatures, we can see that the actually both the charge and the discharge current at some point get to zero. But you'll notice right here, when we dip below freezing, when we hit 0 degrees Celsius, the charge is disabled. And that's in order to protect the cells from sustaining any damage. At this point, though, we're expecting the heating pad to come on. So, in reality, we're still charging in some of these lower temperatures, but this is just the BMS logic itself. So it does need to see the cells, the internal temps, at least above uh, freezing 0 C to take any kind of a charge. But at a certain point, once we get really, really, really cold, the battery's not charging or discharging. Kind of the same thing on the high end of the temperature spectrum. So we'll get to a certain point where it's just too hot and the battery won't let you charge or discharge. It'll basically just sit there and stand by waiting for the temperature to drop. But the key takeaway again is just this sort of safe normal operating range between 10 and 45 C. So the last BMS logic chart to look at here is how does the battery state of charge affect our charging rate? So again, normal range 20 to 90% SOC, everything's good. So in that state of charge range, no issues. We get our full charge and discharge rate. As we get lower state of charge, aka we're discharging the battery, the discharge current is going to start to limit more and more and more closer to zero, while the battery charge current will remain the same. Opposite happens going towards 100% SOC. We can see that our charge rate decreases as we get closer to 100, and then the discharge rate stays that same 75 amps all throughout. One thing I want to point out here specifically related to charge current, once we get into this higher SOC range, so notice all up until we get to 90% state of charge, the battery is going to let you charge it at its full rated current. Once we hit 90%, however, it limits the charge current to just 25 amps. So between 90 to 95%, we're only charging at 25 amps. And then actually between 95 to 99%, the charge current bumps down all the way to just 5 amps. So what's happening here between this 90% and 100% is basically the batteries are calibrating internally, they're balancing their cells, they're calculating their state of charge. So what you'll see is sometimes very quickly during the day when we're charging, we hit that 90% value, but then sometimes to get from 90% to 100, the process is a lot slower. Again, just because the battery is doing things internally to balance out, and then of course because the charge current is reduced. So this is hopefully showing how the scalability is achieved with the V5 battery. So Again, 16 batteries per group without a communication hub. There's no issues here at all. Anytime we have more than 16 batteries in a group, we need the hub. So you can have, again, it's 6 groups maximum, each with 16 batteries in a group. Fully populated system is about 492 total kilowatt hours. These next handful of slides are going to be focusing on battery installation and commissioning. So the next couple here apply to any inverter. So what I mean by that is some of this, to start anyways, is just general battery installation and commissioning. I am using a Solarc in this specific example, but a lot of these steps you can apply to, other inverter manufacturers just the same. So where we're starting here, we're assuming at this point in the process, the installation has nearly been completed. Okay, so what I mean by that is we've got batteries mounted or in a cabinet, our inverters mounted, everything's connected, all of our power cables are run, everything's in conduit. But basically everything is ready to go and to be turned on for the first time. Okay, so before we hit that on button for the first time, and again, all of our power cables and kind of mechanical stuff has been completed. First thing, what you want to check on the batteries is battery to battery communication. So you'll have in a group of batteries a master or a leader battery, and then slave or follower batteries. So the master battery, we start at the master battery and we use those short communication cables to connect one battery to the next, to the next, to the next. And these are all just standard Ethernet cables, again, if you're not using the ones that come with the battery. What's important here is we're going to start at link port 1 on the first battery and go to link port 0 on the second battery, and then link port 1 to link port 0. So at the end of the day, your first battery, port 0 is open, your last battery, port 1 is open. So you have to make sure you follow that specific sequence there between the batteries. So once we've taken care of battery to battery communications, next you'll want to look at battery to inverter communications. So again, my example here has a Solarc, but the process is pretty similar. You're going to make sure you have a communications cable connected from the master battery to the battery COM port on your inverter. Sometimes that cable can be a special modified communication cable with some of the pins being crossed over. In the case of Solarc, specifically, they just use a standard Cat5 or standard Ethernet cable. So we don't have to worry about any custom cables with Solarc. The other thing to look at in this step is the battery dip switches, okay? So these little switches on the front of the battery can be adjusted to tell the battery what inverter it's using, so it knows how to talk with it correctly. We only have to adjust the dip switches of the master battery. Okay, so just this very top battery that's communicating with the inverter, you adjust the dip switches on it, and the switches on all the other batteries in the system, you just leave those off. All right, so we've got battery to battery comms, battery to inverter comms. Now we're ready to turn on the batteries. And you're doing this before we turn on the inverter, by the way. So pretty simple process. All you have to do is turn the power button on for all the batteries. So that's that rocker switch on the front. You turn all those on, and then once they're all turned on, you do a short press and hold on the SW button. That's that red circle button on just the master battery. So 1 to 2 seconds, press and release. What you're going to see is the master battery will wake up first. It'll flash all its LED lights. You'll see it go into standby mode. It'll wake up battery 2, then battery 3, 4, all the way through the group. You're going to wait until all the batteries are activated and in standby before we turn the inverter on. So in other words, we want all the batteries ready to go and reporting before the inverter powers up. To turn off the system, just for reference, it's basically the opposite. You do the SW button, short press and hold on the master, put them all in standby, and then turn the power switch off to all the batteries. You're going to wait until the batteries go into standby before you turn the power buttons off. And worth mentioning too, you want to turn the inverter off or disconnect the inverter before you turn the batteries off. So one really good tip I can give is anytime we're turning batteries off and on or resetting, power cycling them, we don't want the inverter trying to charge or discharge them at the same time. These three slides, by the way, I will say are probably some of the more common issues when it comes to troubleshooting. So if you do have an installation that has a problem, batteries are alarming, we're getting weird readings on our inverter display, something isn't quite right, go through each one of these procedures and make sure that you or your client has followed these. It's not always something to do with these, but a lot of times it is. So these are easy things you can check just to sort of make the troubleshooting process a bit easier. So now we're specifically looking at solar. Okay, so we've got battery to battery comms, battery to inverter comms. Batteries are turned on, inverters turned on, and now it's time to make sure they're communicating. So specifically with Solarc, you'll go. This is happening on the panel, the screen, physically on the inverter. You press the settings button, brings you to this setup menu. Go to battery setup. You'll next see this BAT tab under the battery setup menu. You're going to want to check the use BAT percent charged, activate battery, and BMS lithium BAT. You need to make sure that this BMS lithium BAT is set to 00. That basically tells the Solarc now it's looking for a Pytes battery. Over here, we'll set these to 75 amps per V5. So sort of depends on your installation, how many batteries are there. Once this is all entered, hit OK to save. You'll go back to the main menu of Solarc, click the settings option again. You should now see this button, Lithium BAT Info or LI BAT Info. You'll tap that option and you'll see one of two things. If you see this first screen on the left, that means everything's good. That means that the batteries are talking to the inverter and vice versa. You can actually look, might be kind of hard to see here on the screen, but charge current limit, discharge current limit, those two numbers you should usually line up with 75 amps per battery. So if you put in a 2 battery system and one of these numbers is 75 amps, that means maybe the system isn't seeing both of the batteries. We should see 150 for a 2 battery system. If you click this lithium BAT info button and you see this screen, that means something isn't correct. So this means that there's no communication between the Solarc and the batteries. And at that point, now you can go through and kind of try some of these things or make sure that those previous steps have all been done correctly. So again, all of this can be done in general for any inverter. This slide here specifically was with Solarc, but you can see how easy it is to set this up in closed loop. I mean, we're talking like a handful of button presses, and that's really all that you have to do for the most part. Of course, each application is different. Some instances there'll be more user preference type settings we need to put in, but just to do the closed loop in general is all that we need right here. So next, I'm just going to go through real quick a few installation cases from some of the systems we've done in the past, just to kind of show you how you can use these products and what's possible. So this is one of the biggest systems we've seen so far with V5s. This was in the United States and South Carolina. This had a 3 Solarc 3-phase 15K system, and then 36 batteries in this photo here. They're waiting for 6 more. This, by the way, is custom racking. This is something the customer built, but yeah, pretty large system. It's 210 kilowatt hours of storage altogether with the 42 batteries. I do want to point out here that they have made very good use of those flexible bus bars. So again, if you've got the batteries in one of our cabinets or they're neighboring, the flex bus bars, and then you can see those blue short battery to battery comm cables. Those are both included with each V5. Really easy to use those, and it makes it look, I think, very clean at the end of the day. Some more cases here. This one's in Puerto Rico, another one in North Carolina. Same combination, Solarc with V5, just a different mounting method for the battery. So these are the V brackets. And again, you can do up to 6 high with these brackets. A couple other cases to show. These are both from Puerto Rico as well. More Solarcs. In this case, we're using our VBox OC cabinet. So this is the outdoor rated cabinet, although it looks like both of these might be indoors or housed somewhere. But yeah, 4 batteries in this cabinet, which is 20 kilowatt hours. So once now that we've introduced the V5 and what's possible, I'll touch on next some of the support and resources that Pytes offers to you as installers. So one of the first things to focus on, I think, is battery troubleshooting. Your you know, being an installer, I'm assuming there's quite a few of you, if not all of you, handle your own support and troubleshooting directly with your clients. So when it comes to troubleshooting the batteries, we all hope we will never have to deal with this, but there's always going to be exceptions and little issues that arise here and there. So it's just good to know what your options are. There's I think 2 kind of major ways to troubleshoot batteries. It's going to depend for me whether you're on site or not. So if you're on site, physically present with the batteries and the equipment, you can use our RS-232 console cable. This is an accessory you can get from Charge, or it can be ordered on Amazon. But basically, this lets us look at battery information on a computer physically on site. You can use one of our 2 computer software, Hyperterminal or BMS QT. If you're away from the site, or maybe it's just hard to get to the site, who knows, then you might be doing some troubleshooting remotely. Okay, so this comes back to the SolarMan app. We're using our Wi-Fi dongle accessory on the battery. We can look at it on a web browser or mobile app. And then this is just a basic screenshot of SolarMan. I think this is the web browser version. But yeah, lots of crossover between these 2 programs. It's just a matter of how you want to access that info and whether or not you are on site with the equipment. So our website, Pytes USA, is another really good resource for everybody. We're constantly improving this and making sure the documentation is current and up to date, adding more features and options. But for the most part, under support here, you'll see options for service. You can open a support ticket. All of our downloads, product manuals, integration guides, data sheets can be found here as well. We do offer a pretty, I'd say, robust schedule for tech support, given that we do have staff in North America and China. Kind of helps to cover the duties around the clock for the most part. We do offer full technical support in English, Mandarin, and Spanish. And then we also have a Google Drive, which I can likely share with you later on, which is going to have access to more documentation and information. We also offer system design service. So if you're working on a project, we can help to specify a bill of materials. These are screenshots from a configuration guide we've made for Solarc systems. So this kind of shows some common battery and Solarc pairings with the basic bill of materials to aid in ordering and system design. This one has 6 batteries specifically. We're using our flex bus bars, the VBox IC cabinet. They're stacking 2 of those on top of each other. And then in this case, we're using a couple of bus bars to join the cabinets in parallel. and then a single run of cables to the Solarc 15K. Here we're using the V bus bars. So there's some flexibility here. As I was saying earlier, right? A lot of times you can skip these two bus bars and just use the V bus bars on the Solarc. You could skip all these bus bars altogether and just run a positive and a negative from each battery cabinet directly to the inverter. Maybe the batteries here are physically located a ways away from the Solarc, so it makes sense to bus them at the cabinets and reduce the cable run over to the inverter. So yeah, you're not locked into exactly this solution, and we can do any sort of custom design as well. So if you're doing a project, you don't find what you need in our guide, just let us know and we'll be happy to help you out. Kind of the same thing here, just slightly different configuration, right? 2 stacks of 4 batteries, uh, basically 40 kilowatt hours of storage. This is using bus bars as well to combine the 2 battery stacks, but like I said, those could be skipped in favor of the V bus bars or direct cable runs from each stack to the Solarc. So this next one's a little bit bigger. This is sort of not a fully populated system, but just a larger scaled system. So 32 batteries, 160 kilowatt hours of storage in this case. Because we have more than 16 batteries, remember now we're using our hub accessory. And this example also has 2 inverters as well, so a little unique. But again, just depending on where batteries are housed, distances, what size cable we'd like to use, we may not need all of the busing that's being shown here, but you know what's happening. We're using lower amp rated bus bars to combine the cabinets, and then higher amp rated bus bars between that and the inverters.
Logan, I'm just going to give you a little time check here. We are over time. So if you just want
Okay,
to wrap up quickly and then we can get to some questions there.
thanks. I'm
Yeah,
just about done. I want to
perfect.
show this larger system example with the hub, just to help to connect some of the dots, and then I'll run through the rest of our products quite fast. So
Perfect.
yeah, I'll keep it moving, but again, just showing how do we do these larger systems where we have multiple groups of batteries. Um, we use our hub, common bus for all the batteries, common bus for all the inverters. They all share that. These are all standard Ethernet cables between the batteries from each battery group to the hub, between the inverters even. And in this case, there's a special cable we need from the hub to the inverter, which we can advise on when the time comes. So I'd say if anybody's doing an installation of this scale, don't hesitate to reach out to us. We can offer some input, make sure everything's set up correctly, and make sure it's functioning well. So we set the dip switch on master battery of each group, and then set the dip switch on the hub to match with the inverter. So again, just sort of a more detailed view of a more scaled up system. So keeping the clock in mind, and thanks for the reminder, Tatum. I'm going to try to cruise through these next couple slides as quickly as I can. I know that you all will primarily be using the V5 batteries, but just know we have these solutions too if you run into a project or an application where V5 maybe doesn't fit for some reason. So we do have a 12 volt 100 amp hour lithium battery. This is for mobile marine systems, off-grid cabins, really small scale stuff, 12 and 24 volt systems. This does closed loop with Victron equipment, would be open loop with any other manufacturer. And this one has internal heating as well. This is our sort of flagship cornerstone product. This is the first ESS product we released, the E-Box battery. This is basically the predecessor to the V5. So everything I explained about the V5 applies to this one as well. But this early version does not have internal heating, and it's only 50 amps, 50 amps charge and discharge instead of 75. This is a slightly lower cost solution as well. So maybe if it's a lower power system where we don't need heating, this is an option too. The Pi LV1 stackable battery. This is a brand new release for us. Same 51.2 volt battery modules, 5 kilowatt hours, 100 amp hours a piece. This is something we've designed to go after small to medium scale residential installs. This is an outdoor rated solution. Super plug and play. Ease of installation and speed of installation was one of the main driving factors behind this design. It's a stackable solution, so it's very easy to scale up between 2 modules and 6 in a stack. And then you can have up to 4 fully populated stacks of 6 modules. So it's only about 120 total kilowatt hours with this product. Again, small to medium scale residential stuff for the most part. If you're needing something larger than this 120 or so kilowatt hours, look at the V5. But this is a very easy, clean, sort of streamlined outdoor rated solution. And the depth or the thickness of the stack is only about 9.5 inches, so it makes it a really good option for installing in a garage or tight spaces. Lastly, the last member of our ESS product family, this is our high voltage solution. So it's really similar to the Pi in terms of the architecture. We sort of have the control unit on the top, and then the battery modules underneath it. So one control unit controls multiple battery modules. This right now is undergoing the final stages of cycle and compatibility testing with solar. So their 3-phase 30K and 60K inverters will be compatible with the high voltage battery, and we're expecting to have all the UL 9540 certifications for this very soon too. So again, won't spend much time on this, being that we're out of time, but if anybody has high voltage installations, or somebody's asking you about Solarc 30, 60K inverters, just know that we do have a solution for that. And as always, you're welcome to reach out and we can help you. That's all I got. Thanks so much, everybody, for joining and your patience. I apologize for going over the time, but hope that was very useful info for everybody. And I think we'll open it up now for questions.
Perfect. So there is a Q&A. We have some in there. I have a question here. Can the dry contact be used as an AGS to heat the ESS at night?
Not quite. So the dry contact is really going to be more useful when it comes to responding to signals, and not so much like sending signals out from itself. So if you're trying to do automatic generator start, for the most part, you will, I think, probably be more successful in trying to use the inverter to do that. Like a Solarc, for example, has a normally normally open set of contacts inside of it, which you can use for auto gen start.
Okay, great. We have a question here from Derek. What is the lowest temp battery can be stored at? Lowest operating temp if no external charge?
Let's see. Good question. So I'll need to check on the storage temperature range. That's not on the spec sheet copy I have right now, but I do have that data. I just have to look in a different place. In terms of charging, the temp range is 0 to 45C. Discharging is -10C to 50C.
Great, thank you. We have a question from Chris. Would you leave a dongle on each system so that they could each be constantly accessible online for remote diagnostics?
Oh, yes. Okay. And Chris, thanks for asking that question because I just want to go back um, to that Wi-Fi dongle really quick. Well, look at this one instead. So I'll answer your question. I want to add something to that. Yes, that's the idea. So the Wi-Fi dongle only reports to the internet when it's connected and powered up. So if you have like multiple systems at different sites, you'd want a dongle for each of those systems or each site so you can see it all online. And then specifically with the V5, if you have a larger system where we've got over 16 batteries, you need a dongle on the master battery of each group. So if you had 32 batteries, that's two groups of 16, you'd have two dongles, and then that lets you see down to the individual cells and all of the 32 batteries in that system.
Okay, great. It looks like we have another one here from MD Mac. Can
Mhm.
batteries, so it's a three-part question. One is, can batteries stand vertically on its back? Two is, can you move Wi-Fi dongle from system to system? And three, are batteries shipped direct to Canada or do they go through the US warehouse? Brian, that might be a question for you.
I'll do my best here on these. Number one, can batteries stand vertically on their back? Yes, they can. I don't think any of our case photos show, yeah, not really. This is maybe the closest thing, but in reality, the batteries can be installed in essentially any orientation. Can you move the Wi-Fi dongle from system to system? Yes, you can. But then kind of as I answered the previous question, you're not going to be able to see everything that's happening. So the you have to have the Wi-Fi dongle connected on your system if you want to see the information remotely. I suppose you could have just one and move it from one site to the next site if you wanted to. I'd suggest just get one per site. It's a very, very inexpensive accessory. And I think it would, I mean, I think it would pay for itself almost instantly, if not very quickly. On the shipping question, I'm going to maybe default
Yeah,
to Brian or Austin on that one.
yeah. So we do get the containers directly into
Okay,
Canada, so they
that's what I
are
thought.
through the US.
Wonderful. A question from Steve is, if a customer does not have the dongle, how would software upgrades get applied to the batteries? Is the dongle continuously plugged in to the IoT port or is taken out of the port after monitoring is complete?
So the dongle is something we're intending to have, I'll say permanently or like continuously connected to the battery. Because again, once this is unplugged, you don't have eyes on the system anymore. So if the customer does not have a dongle, you can still look at all the information that the dongle would otherwise provide. It's just going to be through a slightly different method. So that's sort of what I was mentioning here. So with no dongle, no internet, you're on site, and that's the other thing, right? You have to be physically on site with the batteries if there's no dongle. Then you're just going to use one of our computer softwares, Hyperterminal or BMSQT, and it's a physical connection between the battery and a laptop, for example. And this lets you do firmware updates and look at cell data, battery fault history, and things like that.
Okay, great. We have just a couple more questions here. Chris says, does the PI system have heating?
Not yet. It's outdoor rated. The first iteration does not have internal heating, but being that it is an outdoor rated solution, we're working on incorporating that into later versions of the battery. So unfortunately not right now, but hopefully soon in the near future we'll have that.
Okay, and one last question from Stefan. Is there an Ethernet port that can be used to connect the local network instead of the dongle?
Um, there's not an extra Ethernet port on the battery. Are we, um, is that question maybe for a case where we do not have Wi-Fi and there's only Ethernet available?
Maybe.
Okay. Um,
Yes, says Stefan.
okay, okay. So I've had, is there a cleaner and more efficient way to do this than what I'm about to describe? Maybe. I'm definitely will never claim to be an IT expert by any means, but I've had other customers that don't have, maybe they don't have internet and or they don't have the dongle. And what they've done is they sort of just leave a console cable, which is, sorry, got to go through the animations. This thing. They'll leave this console cable permanently connected to the battery and then to, their network or into a computer that they kind of set up on the back end to monitor it in real time. So it works. I know it works. It's just not as streamlined as using the dongle. Hopefully that makes sense.
Great, thank you. Somebody just made a comment here. Some dongles have both Wi-Fi and wired
Right,
option, like Solark.
right. Yeah,
Mhm.
Solarx does. I think ours at the moment it's only Wi-Fi right
Okay,
now.
okay, awesome. So that wraps up all the questions there. So thank you so much, Logan and Austin, for joining us today. And there are some resources in the chat to everyone that Austin put in there. So if you want to grab that link before we sign off, that can be found in the chat. And thank you again for everyone who joined us today. We will send out the recording of this webinar within the week. Thanks again.
Thank you, everybody.